Alright, the second lesson for test 2 is adding and subtracting rational expressions. And of course, the main concern for this section will be pretty much the same as it was for adding fractions. To add or subtract rational expressions, we're going to need a common denominator. And then we can add or subtract the numerators and keep the common denominator, just like we did when we were adding fractions. So the idea here, if we look at this first problem, if they were all like this, then we'd all be a lot happier because these are so much simpler. When we have the same denominator, all we have to do is add the numerators and keep that same denominator, and that gives me 6/9. And of course we always want to write it in lowest terms, so we would need to reduce to get 2/3. Of course, the bigger issue comes in when the denominators are not common. If we want to add 2/3 and 3/4, because they don't have the same denominator, they're not like things. So we can't combine them yet. So we need to find a common denominator. Well, the easiest thing to do to find just a common denominator is to multiply the given denominators together. So if we did that here, we do 3 times 4 equals 12. So then we would want to make each one of the two original fractions have a denominator of 12. So for the first one, we would need to multiply the 3 in the denominator times a 4 to get 12. But remember, we can't just multiply the bottom. We want to end up where we're actually multiplying by a factor of 1, because 1 is our identity element, which means it doesn't change the original. So if we multiply the bottom by 4, we also have to multiply the top by 4. Then for the second one, if I have 3/4, if I want that denominator to be 12, I would need to multiply by 3, and same thing, we got to multiply the numerator as well. So then this would give me 2 times 4 is 8 over 3 times 4 is 12, plus 3 times 3 is 9 over 3 times 4 is 12. Now that the denominators are the same, we can add the numerators. So 8 plus 9 gives me 17 over 12. And 17 only has factors of 1 and 7, so I think that is as low as that will go. Alright, so that one worked out pretty well, just multiplying the two denominators together. But of course, that's not always going to be the simplest thing. If we did that for this second problem, 3/8 plus 5/12, if I just multiply the 8 and the 12 together, then that's going to give me 96. And I would have to multiply the first one by 12/12. And the second one by 8/8. This would result in 36/96 plus 40/96. And then we could add the numerators. And that will give me 76 over 96, which of course is not in lowest terms. So we would have to figure out what common factor. And I didn't know this one offhand either. So I would have to use the calculator, which I assume you would. But it turns out they're both divisible by 4, and it would give me 19 over 24. But there is a simpler process, and of course you've heard us talk about least common denominators already. So the reason that that one was harder is because we found just a common denominator. If we find the least common denominator, it's a little bit more work up front, but it makes the problem that we have to deal with simpler, and that's certainly going to be the case with these rational expressions. So let's look at the 3/8 plus 5/12 again. So my two denominators are 8 and 12. If we want to find the LCD, then we start with the larger number, always the larger. So I'm going to start with 12. I'm going to multiply it times 1. And then I want to know if 8 will divide evenly into 12. And it does not. So 8 doesn't divide evenly into 12. So then I'm going to go up 1. 12 times 2 is 24. And I'm going to ask myself the same question. Will 8 divide evenly into 24? And it does. So that means that my LCD is 24. And you see that's a lot smaller than the 96 that we got just from multiplying the denominators. So if I come back to my original problem, if I have a denominator of 8, I would need to multiply by 3 to get 24. So we're going to do 3 over 3. And if my denominator is 12, I'll need to multiply by 2 on the top and bottom. So that gives me 9 over 24 plus 10 over 24. And of course, once the denominators are the same, we can add the numerators and keep the denominator. So we're really going to want to find the LCD, especially when we're working with these rational expressions, to try and keep things as simple as possible. Now, of course, when we're dealing with these rational expressions, the LCDs are going to look a little more complicated because they're not just numbers. A lot of times they're going to be expressions. So if you look at this first problem, my denominators are x and x minus 1. So to find the LCD, we really want to kind of think about having one of each unique thing. So these two denominators are actually unique. They don't have anything in common. One is just x, one is x minus 1. So our only option here is to just multiply them together. So we're going to need to go through this same process and get these to have the same denominator, and this is the denominator we want. So for the first fraction, I have 1 over x. I want the denominator to be x times x minus 1. So I'm going to write right here what I need to make it look like that. I already have the x, so I need that x minus 1 to have x minus 1. But just like before, if I multiply by x minus 1 on the bottom, I'm going to need to do that on the top as well. For the second fraction, I want that denominator to be x times x minus 1. So I'm going to need to multiply by x to make it look like that. And again, if I do that on the bottom, I have to do it on the top. Alright, so that is now going to give me 1 times x minus 1 is just x minus 1. And it's over x times x minus 1 plus 1 times x is x over, we have x times x minus 1. And now you notice my denominators are the same. So I can collect my numerators over that common denominator. And now all we need to do is simplify it. I have x plus x. That's going to give me 2x minus 1 over that common denominator, x times x minus 1. And this is our lowest term reduced answer because we don't now have any factors that are common to the numerator and denominator that we can